Okay, this is the lecture video for MAC1114 Trigonometry. We're in section 8.4 where we're going to be finding the area of a triangle given either side angle side or side side side. So you see the two formulas associated with each of these cases. In the case where you are given three sides, the values for all three sides but no angles. In order to find the area of a triangle in that case, you're going to find the semi-perimeter first. That's what S stands for, and all that is the perimeter cut in half. A, B, and C represent the values of the sides, the length of the sides. You're going to add up all three, cut it in half. So that's the semi-perimeter. Then that semi-perimeter gets used 4 times underneath this square root. Once by itself times the semi-perimeter minus one of the sides, then a semi-perimeter minus another side, and then the semi-perimeter minus the third side. So you're going to use each of the sides subtracted from the semi-perimeter in each of these factors, and then S by itself. Okay, pretty simple. Area of a triangle if you are given side angle side. Well, in that case, you're going to take the two sides that are given. This will be the angle in between it, because that's what side angle side means, that you're given two sides and an angle that's in between the two sides that you have values for. So you're going to multiply the two sides you're given, cut it in half, and then multiply that by the angle that's between these two sides. And that's what all three of these formulas mean. All three of these formulas. It's just that you might be given side B and C, you might be given side A and B, you might be given side A and C. But in any of these formulas, the angle that you're seeing there must be the angle in between the two sides that you've been given. So this is even less work than this formula. Okay, this one is called Heron's formula, and this one doesn't have a name. It's just the side angle side formula for area of a triangle. So that will be the name. Okay, so what you've been used to up until this point is that you have found the area of a triangle given the base and the altitude. So you've been used to seeing things like this, where you've been given an altitude that comes straight down from a vertex to the opposite side, and then given the base. And in that case, area, the one you're most familiar with, or probably the only one you're familiar with, is 1/2 base times height. Well, you're not going to be given an altitude in these problems, so there has to be ways to find the area given an arrangement of different values, such as side, 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 and side angle side. So the area of a triangle whose base is known and whose altitude is h, whose base is b and altitude is h, the area of that would just be 1/2 base times height. They're using k for altitude. That is not correct, that is not correct, that is not correct. So this is the formula that you have used pretty much every time you've found area up until this class. Okay, moving to example 2. Okay, in example 2, if two sides A and B and an included angle C are known, then the area K is found using the formula. Okay, if this is the case, formula for area would be 1/2. And the two sides they're talking about is A and B. You'll multiply the two sides and finish it off with the sign of the included angle. Okay, so that would be 1/2 A of B times sine of C. That's that formula right there. For number 3, example 3, the area of a triangle where only the sides have been given. So just true to form for my math lab, they like to give you the theorems and formulas at the beginning of the section, in a particular section, and when you're reading the book, which is where some of these problems come from. And then my math lab will ask you questions with respect to those theorems, and then very quickly you'll jump into the actual problem. So when 3 sides are given, you're going to use Heron's formula, and that would just be this one right here. Side, then side minus side A, not side, excuse me, semi-perimeter. Semi-perimeter by itself multiplied by semi-perimeter minus side A, multiplied by semi-perimeter minus side B, multiplied by semi-perimeter minus side C. So each one of those sides gets subtracted from the semi-perimeter, and then one of the factors is the semi-perimeter all by itself. Okay, now let's see what they're doing here. The area of a triangle would be this. You're filling in two different things. This just got slid over here. That's not the right formula. That's not the right formula because it doesn't have the s by itself, and this is missing the square root, so this is perfect for answer blank 1. I'm not going to try and jam that in there. And then they want to know where is the s coming from. The s is just all the sides added together, A, B, and C, and then cut in half. So that would be the answer for question number 2. Okay, in example 4, find the area K of the triangle. Okay, so what you have here is a side, angle, side arrangement of information. Side, then angle, then side. So for that, you're going to be doing the area is, and I'll just write it right here. It's going to be the area is 1/2 times the two sides that you've been given, multiplied by the sine of the angle that is between those two sides. And then you just go ahead and put that in your calculator. Okay, you have 1/2 of 18. And you can just stick it in exactly like you see it if you'd like, if you don't want to do any of the multiplication in your head. Times 3 times 6 times sine of 60. And that comes out to be 7.79 if we round it to 2 decimal places as directed. Okay, find the area K of the triangle. So the area K of the triangle here, let's see, this time we have 3 sides. So this time we're using Heron's formula, and that formula once again is area is equal to semi-perimeter by itself, then semi-perimeter minus A, semi-perimeter minus B, semi-perimeter minus C, where A, B, and C just are the values on each of the sides. Okay, so first we're going to do the semi-perimeter, which is just half of the actual perimeter. The perimeter would be 5 plus 4 plus 7. So the semi-perimeter would be, let's see, this is 9. 9 and 7 is 16. So half of 16, which is the sum of these 3 pieces, which is equal to 8. So 8 is what I'm going to be using over and over again underneath this radical. So it's 8 by itself, then it's 8, take away one of the sides, 8, take away the next side, doesn't matter what order you do them in, and 8 minus that remaining side. I would get a single number. You have to get a single number underneath this radical first before you take the square root. So it's going to be 8 times 3 times 4 times 1. Okay, so that is equal to 96. And then when you round it to 2 decimal places, it's because you have then applied the square root, so second square root 96, and then you can round it to 2 decimal places. So this will be 9.7. Let's see, this is going to round up to a 10, and part of that will spill over into this category to the 10th place. So this will be 9.80. Rounded to 2 decimal places. Okay, so that's example 5. Okay, then let's see. Then we're going to go to number 6, find the area of the triangle. This time you're just drawing it yourself, so you can draw it any way you like. Do put an A, B, and C on it so that you can tell where the specific sides are and angles are that they're giving you. So this would be side A. They have not given us anything for that, so let's just leave that as an A. This would be side B, which they have given. And this would be side C, which they've given as a 5, and then they say angle A is 80. So this turns out, after drawing it, that you are given side, angle, side. And because you're in the side, angle, side situation, the formula becomes 1/2 times the two sides, finally multiplied by the angle in between the two sides you've been given, which are 2 and 5. Okay, so this is half of 10. 2 times 5 is 10. Half of that is 5 times sine of 80. And again, you can just press it in just like this. 0.5 times 2 times 5 times sine of 80. I just did a little bit of it in my head, so I don't have to press in as many things. And then let's see, I believe they said round this off to 2 decimal places once again, so that would be 4.92. Okay, moving to example 7, where we're mixing a triangle inside of a circle. And let's see, it says find the area of the segment. Shaded in blue, well, that's going to be this right here. The blue didn't come out in the copy. So they want you to find the area of that little piece right in there of the circle whose radius is 4. Okay, so radius is 4, formed by a central angle. That means an angle at the center of the circle of 65 degrees. Subtract the area of the triangle. They give you a little hint here. Subtract the area of the triangle from the area of the sector. That means you need to know both formulas. So for area of a triangle, you have 2 sides that you already know, because if the radius is 4, it's 4 no matter which direction you go in, as long as you go from the center to the edge of the circle. So you have 2 sides and an included angle. So the area of the actual triangle here would be using that side angle side method for finding the area of the triangle, which is just 1/2. Multiply the 2 sides together, and then multiply by the sine of the included angle. And you can pop all that into your calculator. Half of 16 is 8. 8 times sine is 65. And that is 7.2504. And I'm going to carry that out just a bit more, because this is not the last step of the problem. So we're not really ready to round off to 2 decimal places. Okay, so let's see. Then we're going to do the area of a sector. So I did this, and now I'm going to do the area of a sector. That means you need that formula. Area of the sector looks kind of like a piece of pizza pie, or just a piece of pie. It goes from the center all the way out to the edge. So the whole plan here is find the area of that sector that goes all the way out to the edge, then subtract the area of the triangle from it, and you'll be left with that little piece right here. Okay, so let's see. Area of a sector. Okay, there's a specific formula for that, which I'm going to remind you of. Area of a sector is equal to the angle you're talking about, but in degree form. If it's given in degree form, you have to compare it to the total number of degrees that are in the circle, which is 360. So you know what fractional portion of the circle you're talking about when you're working with this sector. Sectors can be all different sizes. Do they represent 1/3 of the circle, 1/4, 1/2, 1/5? And that's what you're figuring out right here. So you're comparing the number of degrees for your central angle to the overall number of degrees. Because if this is 65, that's 65. You want to know what portion this is of the entire circle. And then the rest of the area of the sector formula is that you then have to multiply that by pi r squared. And what you're really seeing here, pi r squared, that's just the formula for area of the entire circle. But you're not doing the area of the entire circle. You're only finding the area of a fractional portion of the entire circle. So it's area of the circle times the fractional portion, and that will give you the area of the sector. So just reminding you that pi r squared is area for the whole circle, and this will bring in the fractional portion. So we're going to compare 65 to 360, and then we're going to multiply it by pi r squared. Okay, so we can do, just put it right in the calculator like that. 65, these degree symbols are going to cancel out. So it'll be 65 times pi times 16, then divided by 360. 65 times pi times 16, that's the 4 squared. Get that numerator answer, then divided by 360. And what you get at that point is 9.075712, 9.07571. I'm going to go one more place just for accuracy in my final answer. So this is one of the steps. This is another step. And then your third step is where you're going to carry out the hint, but you need these two answers so that you can comply with this hint. Okay, so let's see. We're going to do area of this entire sector, which incorporates the triangle and this piece that you're going after. It includes both of those. And then we're going to take out the area of the triangle. And that will be equal to the area of that segment, that little partial moon segment that you see right there. So area of the sector, that turned out to be 9.075712. Then we're going to subtract the area of the triangle, which turned out to be 7.250462. 7.250462, and that'll give us the area of the segment. Okay, so 9.075712 minus 7.250462. And that's going to be 1.83 that we can finally round to 2 decimal places. So 1.83 square feet. Because if this is in feet, the radius is in feet, area is always in two-dimensional units. So you could either put ft squared or write it out like that. Okay, so that's number 7. And then this is our last problem. Very short section. You're only doing area 2 different ways. Okay, so let's do one more of these. So you've gotten a couple of examples of Heron's formula, a few examples of the side angle side, and an application problem. So here we have, and you know, when you just have 3 sides like this, you don't really have to draw it. I mean, I will anyway. But you can clearly see that you have 3 sides, because that's what these lowercase letter means. So you actually could have just jumped into the actual calculation. So by Heron's formula, we're going to find area. And this is the formula. I'll write it just to help you memorize it. It's semi-perimeter by itself, then semi-perimeter minus one of the sides, semi-perimeter minus another side, and then semi-perimeter minus the third side. Okay, we'll have to do semi-perimeter first, which is just 1/2 of the perimeter. The perimeter would be 15 plus 18 plus 13. Okay, and that's going to be 1/2 of 15 plus 18 plus 13 is 46, and half of that is 23. Okay, then once you get S, that's after you get that, then you go to the actual area formula. And you do square root of the semi-perimeter, and then you'll use the semi-perimeter with each side. So a lot more work than the side angle side formula. Doesn't matter which order you do these in. Just make sure you use the semi-perimeter with each of the three sides. I did the 15, the 18, and I still have the 13 left. Then you want to get a single number here, so keep going with that. Let's find the differences here. We have a 23. Here we have a difference of 23 minus 15, so that's 8. Here we have a difference of 23 minus 18, so that would be 5. And here we have a difference of 23 minus 13, so that would be 10. Now going for that single number underneath the square root, 23 times 8 times 5 times 10. And that gives us 9,200. And then finally we can approximate it once we take the square root. And we're going to be rounding that to 2 decimal places again. So second square root, toss in that answer, and we get 95.92. Okay, and that completes your examples for section 8.4.